Hi guys, hi girls, and welcome to another video on the DANSETTE AUTOMIX. Yeah, we're gonna try and get this one sorted out if we can. Now let me get my box of wire, which I like to have, because the box of wire comes in handy. We also want a 1K resistor. We need a 1K resistor. So that's, ouch! Ah, what have I just trod on? I just trod on something that hurt. So let's have a look in my box of resistors. Let's find a 1K resistor. Right. Let's have a look. 1K point 2. They're too small. It needs to be a bit bigger than that. 1 meg ohm. 3K 33. Yeah, we need. There's a 1K. Nope, no good. Too small. Oh, we need a, well, there's a 1 ohm. That's no good. 10K to 15K, that's no good. 1 ohm. $1K. What are these ones? Yeah, I think one of these will do. Yeah, I think one of these will do us. Right. Turn the light on. Turn the soldering iron on. Right, move this wire over here for a minute. Alright, this is the circuit, the chassis should I say. Alright, put the circuit there for a minute, because I don't need that just yet. There's the diode. And where's the original 1K that we had in it? There's the original. We haven't got a test meter on this bench either, you know. Fancy having a bench and no test meter on it. So now having a test meter on the bench. Okay, now. There we go. Well, we got the, what do you call it, working, guys. Just on a, to move diversify for a second. We've got the, what do you call it, working, the Harvard Bad Buddy. But that's not working. I got a check on it this morning. I went on this morning and got a check off someone and it worked. It transmits lovely. And it receives. There we go. Let's zoom out a bit. There we go. Now let's just check the original resistor. Because if the original's in, we'll put the fucker back in. If it's not, we won't. Well, we might put a new one in anyway, but... Let's put it on the right. Put it on the right setting. 1.2K. Oh, that looks okay, but we'll, what colour is it? Brown, black, red. Brown. We may not have one. What's this go up to? Put 1k to 2k. Might not have one. Got one here. It's got 4 rings on it. What is it? $2k. No good. Well, it probably would work. We may end up having to put the original back in. What's this one? Yeah, these are all 2k, these. And these are all going to be 2k. I think I've had all the 1k ones out of this. Got to put an order in for some 1ks. Yeah. Never mind. We'll put the original back. We'll use the original because it's in range. And it went to the rectifier because that's where it snapped off. So let's have a look at the circuit. Yeah, it comes off the rectifier. And it goes across these two. Well, how does that fucking happen? Let's just clean this up. So what we'll do, we'll clean, snip the end of that off because we're going to struggle. Now what we'll do, we'll just clean, straighten this. Yeah. Try not to break the fucking resistor. Straighten that. And this is actually still in good condition, it's still in tolerance, so clean the that's it. Clean this end. Make sure we've got a nice. There you go. Right, so according to the circuit, that's a ground, so I don't have to worry about that at this point. So according to the circuit, we also need some heat shrink. Wherever that's gone. Where's my heat shrink? We need some heat shrink. Don't know where my heat shrink. Oh, well, maybe not. So let's have a look. So I think what we'll do, guys, we'll do it the way we always do it. We'll do it the way we always do it. We'll do it the way we always do it. Right. And what we'll do, put our resistor in there. There you go. fill that up. There you go. Now what we can do, we can bend the resistor like that, and then we can bend and do it like that. Maybe not quite like that. We need the bend to be the same way as the other way. There we go. Straighten that. There you go. That's it. Now we'll let go. So that there, straighten that and bend it there. Then what we need to do is clip that off because we don't need that. And we'll do it in a minute. This one, straighten this. We'll see if that'll fit in there. If it does, then we can put the resistor there. Perfect. That's exactly what we want. Now all we do is clip that so it's the same length. There you go. Put a bit of solder on the resistor. Right, now this is how they want you to do it. Now we may have to hold the resistor like that. Be careful not to crush it. Oops. Yeah, I would have liked to have put a new one in, but I ain't got one, so we're going to use what we've got. As the Americans say, run what we've brung. So we've got this, so we're going to go with it. So let that solder settle up there, which it has. Now this one. There we go. It's going nowhere. Now the rectifier, the new rectifier that we're going to fit. Wherever that's gone, there it is. Now, what we could do next is we can curl. The curly pliers are in the other room, they're in the shack. I need to get some more new pliers and stuff. So just give this a scrape with a knife to get any crap off the ends. Do the other end. There you go. Yeah, because we had one end of the resistor going there to the plus, which comes off. That's the minus there, which is your Yeah, other side to chassis. This side faces up. So what we do next, put a curl, put a little J hook in that. And squeeze it just a little bit. Put that, hook that into there. There you go. Get that soldered in. There you go. Leave that there for a minute. So what we do next is we can bring that to there. Then we can, and this is our HT. Yeah. Make sure, look on the transfer thing. Yeah. Yeah. That's our HT because that's where our fucking yellow wire fell off. So what we'll do next, we'll go into our wire box. Let's go into our wire box and we'll put an orange one in because they're a bit shorter and there's no point, we don't need it too long. So I'm sure you can see what I'm doing. Right. So what we'll do, we'll bend in there. Put a bend in there. Hook them together. It would help is when you crushed them, they would actually crush like that. So we can get a really good mechanical connection. So I've got it. It has. Then all we do, we can put that there. We can put that there, which is out the way. And we can that goes to there, so I want it out there, so I'll clip that off. There we go. solder on that wire. Solder that. To there. Right. They're our speaker, we don't have to worry about them, they're a speaker. There to the speaker. So we've got so now we've got our capacitors connected. We've got our capacitors connected. Our resistor is connected here, which will connect the other node. Hang on a minute, what's happened here? Just check this. So we've got that black there going to negative, that's correct. That black there going positive, that's correct. That going to positive there, that's correct. That going to yes, it's correct. I just wanted to check, guys. You always check your work. You check everything, no matter what. Check everything. Anyway, so we're right. That oil's fell over again. It's not spilled, but I don't want it spilling, so we'll put it there. Right, so according to this, we've done, exactly what they want you to do. We've come off, hang on, I've put my diode on the wrong way around. Have I? Yeah, I have, idiot. Oh fucker. Put my diode on the wrong way around. I'm going to get that off there. I'll have to click that. There you go. Yeah, I put my diode on the wrong way around. That's why we check these things, guys. That's why we check these things. That's why we check everything. Right, so that should go to, that should go that side. Put some more solder on there. Yeah, that should go that side. It's fucking hot, guys. There we go. Is that good enough? Yeah, it's not going anywhere. Now all we do, just solder that wire back together. Yeah. So you have to, see, that's why I say, guys, double check your work, because you always make sure that everything's right. Always double check it. Don't matter what you think, don't matter who you are, what sort of qualified engineer you are, whatever, make sure you check everything. Now that's right now, because that's coming out of here, going down there, and that's how it goes. So that's the HT wired. Right. So let's double check everything now. Make sure that's nice and straight, everything is, yeah. Now if I can put that, we don't want them. I mean, I would like to have, I might even sleeve that yet. We'll decide. We will find the heat shrink, it's here somewhere. We will probably sleeve that, but we just want to get everything right for now. And that's all okay. Off there. Because we're going to put new, well, we can leave this is alright. Going to the on off switch, this is alright. We're happy with that. It's not the original, but it's okay. I'm happy to let that go. We will put a new power lead on here. So basically, what we've done, guys, we've done the same as it says on the circuit. We're coming off the. If I move this and put this on the bench, we see it. Move it out of the way. Right. Turn this meter off. There we go. Zoom in a bit and I can show you. We're only interested in the power supply. Right. So if I move this up a bit, there you go. We're only interested in this section here. Alright, so we've got, let's get the pointed one. That way I won't get this fucking wire brush stuck in my arm. Right, there's your secondary there. Here's your primary. Going in here, there's your motor, your on-off switch. There's your on-off switch. There's your motor. Goes to there. Now what we do, we have another on-off switch here. This is a double pole on-off switch. This. So basically, let's move that solder. Basically, this is the secondary. We're going into the diode and then out to the 1K resistor, and that goes across both capacitors. Well, that's like if we bring the circuit back, the unit back. Let me get that in position for you. Now, as you can see, that's how we've done that. There you go. That's how we've done that. We've got a 33 UF there, a 33 UF there. And we've got the diode, if we just bring it round a bit so we'll show you. There's the diode. You can just see the diode there. And that's how we've done it. And that's how we've done it. We will put a fuse when we find the fuse holders. We will put a fuse in this. But this is how they want you to do it. This is how they built the power supply. I've not put a limiting resistor across here, a voltage drop resistor. I don't think, to be honest, I don't think we need it. I will look at the specs for the valve, but I don't think we need it. If we do, we'll put one in. But honestly guys, I don't think we need it, because if we look at the circuit, I'm too far up. See, I've not got a monitor in front of me. So, there you go. There you go. Right, as you can see, the voltage is on the A, which is here, is 130 volts. We've got 110 volts on the B, which is the screen of the valve. The A is on the anode. Well, yeah. A is on the smoother. So we're going to have, we may have a bit more coming off there, but it'll dissipate as it conducts. So we're hoping for that to happen. Then we've got 110 on B, which is the screen. On C, we've got 105. Which is anode. We've got 105 on the anode. And we've got 5.5 on D, which is the cathode, and this here is your control grid. And you haven't seen a fucking bit of that, have you? Let me move over. Let me move you over so you can see it. Right. You saw what I wanted you to see, actually. There we go. Let me get this in position. Right. Right, this is the amplifier side now. Right. Let's get that straight. There you go. That'll do. Right. So we've got A, which is coming off MR, which is coming off RM1, which is rectifier metal rectifier 1. So we've got 130 coming off there. Then we've got the 100k resistor, sorry, the 1k resistor. That then goes to UL41, goes to the screen, which is here, of UL41, which is on the B. And that's 110 volts going to the screen. Then on the C, we've got the anode, which is connected to the output transformer, and that comes off. That's on the C, and that's 105 volts on the C. Then on the D, we've got 5.5 volts, which is here, which is your cathode. Your heater is 40 volt, for about 40 volts, 45 volts or something fucking daft on these. It doesn't tell you the heater voltage. There's your bulb there, 6.3. You've got a winding here at the end, which is your bulb, which is 6.3. Which is, well, they've got it at 6 volts, but usually 6.3. You've got this wind center tap, which is your heater, which is going to be your 40 something volts for your heater. Now, in theory, you could use this transformer in any of the other Dansette models. Where you use an E series, you just wouldn't use that center tap. You'd leave that off. You wouldn't use that. So basically, that's 52 microfarad. That should be 16, but we've gone for 32s. It'll work. And the 400 volts each, and that one there should be 50 microfarad. What are we going for there? I think we went for a 22. Yeah, I think we went for a 22. It won't do any harm. I think we went for a 22. If we did, we may have to change that. Yeah, we did. So we may have to change that one. Yeah, put a 47 in there. because we haven't got a 50. I forgot, I thought it was a 22, they usually are. Yeah. Yeah. We may change that, we'll see how we get on with it. See how we get on with it, we may change that. We can still get interchange stuff, so it's no problem. We can still change stuff, so it's no problem. But yeah, that's basically, guys, that's basically the power supply built. I mean, this circuit, I mean, this is actually a revised circuit. This is not the circuit that Dansette made. This is a circuit that somebody else has drawn. This is not Dansette's, because the actual Dansette circuit had a 25 UF for the cathode. That I do know, because I have seen another copy of this. I've seen the Dansette copy of this. I just can't find it. So I have seen it. So anyway, what we'll do for now, guys, I need to dig out my power lead, so we can put a new power lead on this. You know, so what we'll do, we'll dig out some power lead, we'll put a power lead on it, and we'll plug it in and test it. Hey. Right, so what we'll do, we're back. Well, we've never really been anywhere. Right. What we'll do now, we'll put a power lead on it. Fucking hell. There we go. We get a power lead, and zoom out a bit, put a power lead on it. That's it. Thought there was something wrong there. Wouldn't go all the way. So what we'll do, we'll put a power lead on. There we go. A nice piece of this lead. That should do it. There we go. And there you go. There we go. Soldering irons on. There we go. Now let's decide how we're going to do this. Looks easy enough. What we're doing, guys, we're going to put a new power lead on. But what we're going to do, we're going to put one of them unsafe ones on, you know, the ones that have an earth in them. Someone says I do it unsafe. So we'll put one of them unsafe ones on. You know, the unsafe, really bad ones that have an earth on them. They'll do a really nice job. Make it as safe My best wire strippers are actually in the shack. So we're going to use the Stanley knife to strip the wire. I would use my mouth, and I just broke a fucking nail, believe it or not. I thought that was something that women only did. But no, obviously men can do it as well. That's that one. Now the earth. Do we need an earth? There you go. Now, what we'll do next, we'll tighten all this together so it's all nice and neat. There we go. I hope that leads long enough. Should be. Should be. Right. Now what we'll do, take off. We need to put that on as well. Off there. Don't know where my sucker is. I did do, but I don't know where it is now. Don't think I need it, to be honest. No, we don't need the sucker. All we do is we just heat that up. Feed the wire through it. Thought that went through too fucking easy. Well, that was too easy. There you go, it's gone through. There we go. Get the solder. There we go. Solder that. Into place. Gotcha. Beautiful. Now why is that connected to there and goes to the ground? Why have we not got a wire coming from the grid? Unless that's the wire there that comes from the ground of the grid. I'll have to check. I think it goes down there. Check this out. I think this has all been off and I think it's wired wrong. take all that out in a minute. There we go. We can put the fucking power lead on first. Oh, fuck's sake. You know, that dog was quiet before. As soon as I start doing this, it starts wandering about. There you go. That's in. Bend that over. There you go. Now we'll have a look. I don't think the grid should go there. The pickup. There you go. So we'll put the earth on in a minute. We'll just have a look at the circuit. And have a look where our pickup goes. Our pickup, there's our ground there. We're going through, yeah, we're going through the 1 meg ohm pot. That's your ground to your pickup there, and that should be your positive, which means I've got a feeling that this has been off. And if I turn this on, so that's going to the, that goes to earth. The pickup wouldn't go to earth, but the positive side of it wouldn't. But it does, you know. Well, actually it doesn't. There's your pickup there, one side of it, and that's your negative. This side of it, yeah, this is being off. This goes on the other side. There you go. That's soldered on. Yeah. Yeah, that goes. That goes on there. And this one can go across here, and we can put a bit of solder there and take that, should go there. If we can ever find the fucking solder, there it is. There it is. So we'll solder that. Put a bit of solder on here. Like that. There we go. away. There you go. Because we can sort that out. We can put a little bit down there probably to sleeve that, because I don't like that. No, I wouldn't like that to touch anywhere. Definitely not. Anyway, our earth. Could go on there. We can earth this here, and this will earth absolutely everything. That'll earth everything. Now, this earth here, we take that off there, a broken wire. We get a new one out of the wire kit. There we go. Ooh. Now get this one, get a new one. Well, that won't fit. Should do. Solder. And that needs to be soldered on and all. That lifted off. That gonna stay? Yep. And that we can put some wherever it's gone. Where's the fucking solder gone? I think I've just lost it. No, it's there. Well, yeah. Well, get another piece. There we go. There you go, guys. What we'll do is solder, put some wire solder in there. And this will be our there we go, that's our earth. Now we need to look at this. That's one he's put in, it's okay as long as it's okay. So what we'll do now, we'll get the meter, make sure that there's an earth everywhere we need one. Especially there you go. Right. Continuity. So if we go to we can go to the earth here because it goes to the end of the power lead. That's it, we're pushed in. Yep. 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 The speaker, I don't think uses that sort of system. We need to bear them wires anyway ready. The speaker wires ready. The speaker. There we go. Right. Now we've got our earths where we need it. We'll sort that grid wire out as and when. Be alright there for now. There we go. And we look. Not forgetting to put the valve back in, obviously. We'll see if this works. Now, connect that into the safe block. Now when we're talking about the safe block, we're getting near. Right, is this the safe block? It is. Live. Earth. Neutral. That's all connected to the safe block, or as we used to call it years ago, the Lenny box, which was live earth and neutral. Right, so we'll put that on DC. Now we need a speaker, or at least a lead. We've got a speaker there, we just need a lead for it. So let's see, we've got a lead in this box. Did see one. Don't know if I could use. No, I don't want to cut that because that's a good lead. Don't want to snip it. Don't want to ruin a good lead. And I haven't got a fucking speaker handy. Oh, what we'll do, we'll take the test speaker off the windowsill. We can take this. To use this speaker because this is. Ooh. This is our test speaker anyway. Ooh. Oops. Let's move some of this move these records, are gonna fall off the side. Put them there. There we go. That keyboard. That can go, I don't think it works, that keyboard, can't remember. I think it might do actually. I know I've got one that doesn't. But might. Right. Now connect one side to the other. One side to the other. Now this amplifier came in with a lot wrong. We've done a lot of work on this over the last couple of weeks. Now let's get the, have I got a, see if I've got a clip lead for the negative. Clip lead, clip lead, clip lead. I've got one. I got a piece of easy feeling. There we go. There's our clip lead. Ouch, my knee. Let's get our valve. Let's get the valve. There's the valve. Right. Right, where's the tit? There it is. Now make sure that we're all connected. We look it. That's ground. That's valve heater. Should be. Right. Now. Now. Where's that black clock clip? It is a bit broken, that, but it should probably do the job. Shove that end into there. Shove that end to that, if it would help. A bit damaged this lead. There you go, onto the earth. Now, no, we don't know. Right, 155 on there. $140 on there. So we're getting something about up here. Yeah. Right, so we want to make sure we're, as I've got the volume turned up. Yeah. Right. Make sure nothing's getting warm. No, we're good. Hang on. 137. Well, the valve was a bit bright then, it's not. It's the bulb behind it. So let's turn it off for a second. There's no hum there, guys. Let's see how fast it's dissipating. Should be pretty quick. It is, there's nothing there now. Let's have a look at the tone. Alright. Move that out of the way. Right. Keep that out of the way, that grid. We don't want it touching. Right, so what we want to look at, guys, we want to look at A, which should be 130. Which is 149, but there again it will come down that once it warms up. Not bad actually. This side should be 103, which is not bad, because on the circuit it says 110 for the screen. Right, and the grid, sorry, the cathode is 5 volts, 5.8. So let's see what the circuit's telling, see what it's telling us. So we want 130 on here. We've got 140, we're a bit high. That's alright. And on C, sorry, on 10, sorry, on A, we want to see 130, we're getting 140, that's alright. 110 on B, which is your screen, which is here. That's 102, so that's a bit low, but that's alright. And this one, 5 points. Yeah, D is 5.5, and we're 5.5 exactly on D. So that, guys, is that repaired. So that is repaired, guys. That's working now, that amp. That can go back in. That can go back in now. We'll put it back in tomorrow, because to be honest with you, right, we'll do that. We'll put that back in the chassis, back in the cabinet tomorrow, and we need to charge the meter up because we're running low. So turn the soldering iron off. Also, I wanted to check, which I didn't. Let me just put it back on, make sure the volume goes down. Make sure the volume goes down, make sure we've got that grid wire, that volume wire in the right place. It should be, but I'd rather check. So we can check that right now. Turn that back on. Right, so we know that's in the fully up position. So if I turn that down to there, That's fully down. Yeah, I can't hear anything. Let's turn that up. Yeah, he had the grid wire wrong, that's why he was getting no fucking volume. I mean, leave it to me, guys, leave it to me. I'm the professional. I'm the professional, I know what I'm doing. Leave it to Andy. We just need to tidy this up a bit now. We're working now. That's the main thing. We might change that tone capacitor. We don't know yet. But yeah. Yeah. So that, you know, that pretty much concurs. Apart from the voltage at the very beginning, the HT coming off the rectifier. Apart from that being 140, all the other voltages are pretty much right. They're pretty much where I expect to find them. So what I'm going to do, guys, I'm going to sort this video out for you tonight, and we'll do the final part on this tomorrow. I know it's been a bit drawn out, but we've got there. Like, share, subscribe, buy me a coffee, all that other good stuff if you want to. Tell everybody how good this channel is, and I will be back this way tomorrow, guys. Thank you very much. Bye for now.